Hello students, welcome to Getronics for You. In this video, we are going to discuss about the temperature equivalent voltage. So let's start the topic. Temperature equivalent voltage is sometimes called as thermal voltage. We will denote this thermal voltage by terms V suffix T. Now, what is the physical significance of this thermal voltage? For this, let us consider a semiconductor device. So let us take or assume that it is a semiconductor device and it is the output port and this is the input port and this is a semiconductor device. Now, suppose in the first case, the temperature of the device is T1 and we have given some V input voltage Vi and we have got V0 1 voltage at the output of the device for the first case when the temperature is T1. Now let us assume that the temperature of this device by some means has been changed to T1 to T2. Now due to this temperature change, there must be some change in the phenomenal characteristics of this device. For that, we will get a change in the output parameters. Now, for that, if you see, the output is in the voltage dimension, but the change that is happening, it is in the temperature dimension. Now, due to this temperature change in the semiconductor device, there will be some output change because some extra phenomena will take place due to the increase or decrease of temperature from T1 to T2. Now, what we have to take that we have changed the temperature, that is change in temperature. Let us assume that it is del T. And for this change in temperature, there must be in the change of output voltage. So we have to convert this information, that is the change in temperature, to equivalent voltage. So the equivalent voltage due to the change in temperature is nothing but the thermal voltage Vt. That means we are converting the change in temperature into the change in voltage, and that is nothing but the thermal voltage. So Vt is the thermal voltage. This Vt is given by our equation Vt is equals to Kt by Q, which is very important for the GATE exam purpose. Vt equals to Kt by Q and the unit will be volt. Now you can see that there is a question written how to incorporate the information of temperature in the electronics device applications, and the only way to incorporate the information of the temperature change is by thermal voltage that we have already discussed, and this thermal voltage is given by Vt and it is equals to Kt by Q, where K is the Boltzmann constant and T is the temperature always in Kelvin or degree Kelvin, and Q is the electronic charge, that is 1.6 into 10 to the power minus 19 coulomb. So far we have seen that the thermal voltage Vt is given by the equation Vt is equals to kT by Q, where K is the Boltzmann constant. But this Boltzmann constant is originally written as, this equation is originally written as Vt equals to K bar Kt by Q. This is also, this K bar is also the Boltzmann constant. But so this K bar is also a Boltzmann constant, but this K bar is nothing but K into Q, where this Q is the electronic charge, or we can say that K is equals to K bar by Q. So if we find the value of K and Q bar, so K bar is given by K bar and K both are Boltzmann constant, only K is equals to K bar divided by Q. So K bar is, the constant value of the K bar is 1.38 into 10 to the power minus 23 joule per degree Kelvin. So if we divide this K bar by Q, that is 1.6 into 10 to the power minus 19 coulomb, then we will get the value of K, and K is equals to K bar by Q, which comes out to be 8.62 into 10 to the power minus 5 electron volt divided by degree Kelvin. So for the examination purpose, we have to remember this constant value, this K bar and K, and in the equation of Vt there is K bar, so we have to use the term K bar. We cannot use this K value in this equation or thermal voltage equation. Now let us look at the thermal voltage equation. So we can see that the Vt will have the unit of volt. If I substitute the value of K bar and Q, so we know the value of K bar. K bar is given by this equation, and Q value is nothing but 1.6 into 10 to the power minus 19 coulomb. So if I substitute these two values, so Vt will become Vt equals to capital T, that is temperature, divided by 11,600, and the unit is volt. So this is the another form of the thermal voltage, and this equation is also very important with respect to the gate examination. Sometimes they gives the value of temperature and they told to find the value of Vt. So in that case you have to remember this equation. From this equation we can see that the thermal voltage Vt is proportional to temperature. As the temperature increases, the equivalent thermal voltage is also increased. So for this case, if the temperature is 0 Kelvin, for this case the Vt or the thermal voltage will be 0 volt. And if the temperature is 300 K, that is the room temperature or normal temperature, then Vt value is equals to 26 millivolt. If we put the value of T here in the Vt equation, and T is 300K, then we can find the value of Vt as 26 millivolt. This case is very important with respect to the multiple choice question of GATE examination, because sometimes questions come, the thermal voltage of the room temperature is dash, then and the answer will be 26 millivolt. Now if we see the equation of the thermal voltage, that is Vt, then we can see that the from this equation also we can say that the thermal voltage Vt is equals to capital T, or temperature, divided by 11,600. So from this equation we can see that the thermal voltage has a very high value of denominator. This denominator has very high value. So we can say that for large variation of temperature we will get very small variation of thermal voltage. This conclusion is very important with respect to this equation. So if we vary the temperature in a large value, then we will get an equivalent thermal voltage of very small value. And another conclusion that can be drawn is that from this equation is the standard room temperature corresponds to 26 millivolt of thermal voltage. So this is all about the voltage equivalent of temperature or thermal voltage with respect to the electronics device. If you have enjoyed this video about this thermal voltage, please do share and subscribe the channel to get more video updates in the upcoming times. Thank you.